Okay, this is the second part of a brief review on derivatives. So we're going to be looking at chain rule, derivatives, exponentials, and logarithms. So we're going to start off with finding the derivative of the square root of 2x squared plus 3x plus 5. So recall that square root is the same thing as 1/2 power. So we'll go ahead and rewrite our function with a rational exponent. And then we're going to do the chain rule. Derivative of a composition of f composed of the g of x is equal to the derivative of the outside function with the inside function inside times the derivative of the inside function. Okay, so for our example here, the inside function is 2x squared plus 3x plus 5, and the outside function is the power function x to the 1/2. Okay, so we're going to go ahead and take the derivative, and so we're going to apply the power rule. So the 1/2 comes down, and then it's your base. Subtract 1 from your exponent, and that becomes minus 1/2. And then the chain rule part, we take the derivative of the interior, and the derivative of the interior is going to be 4x plus 3. Okay. Typically, we'll not leave the rational and the negative exponents, so the 4x plus 3 is going to be in the numerator. The 1/2 will become a 2 in the denominator, and then we got the negative exponent there, so that'll come down, and 1/2 power is the same thing as the square root. Okay, so we'll do 3 more examples, so try to keep this one fairly short. Alright, so this time we're going to look at finding the derivative of the sine of the natural log of 5x. So just as a reminder, derivative of sine is cosine. The derivative of the natural log of x is 1 over x. Now if we do the derivative of the natural log of u, where u is a differentiable function of x such as 5x, that's going to be u prime over u. That's the chain rule that gives us that u prime. And we actually have a composition of 3 functions: sine, natural log, and 5x. So there's 3 functions there. So to use the chain rule with 3 functions, h composed with f composed with g of x, it's going to be the derivative of the outside function, which is h. So it's going to be h prime, inside function, which is f of x and g of x inside, times the derivative of the inside, which is the derivative of f of g of x, and that's just your regular chain rule, so that's going to be f prime of g of x times g prime of x. And so we're going to follow that pattern when we take the derivative here. Okay, so we're going to first take the derivative of the outside function, which is cosine, and then the inside function, natural log of 5x, is just there. Okay, then times the derivative of the inside being the natural log of 5x, and so you're going to follow the rule here. Okay, so I didn't quite follow the rule here. I'm breaking it down slightly more, so it would be u prime, which would be 5 there. Okay, so I'm going to go a little bit further there, so just break it down all the way to follow this pattern here. And then times the derivative of the g of x, which is, in this case, a 5x, and derivative of 5x is just 5. Okay, so we'll go ahead and simplify that, and we get cosine of the natural log of 5x all over x. Okay, all right, let's see, 2 more we're going to look at derivatives of some exponentials. So we're going to look at finding the derivative of e raised to the sine of x. And then recall that the derivative of e to the x is e to the x. So if we have e to the u, where u is a differentiable function of x, then chain rule is going to give us the u prime and then the e to the u. Okay, so by the chain rule, the derivative of the sine is cosine. So cosine x, there's your u prime, and then e to the sine x, and that's it. Okay, moving on, we're going to take the derivative of 5 raised to the tangent of 2x. Okay, so the derivative of b to the u, so this is an exponential base other than e, the base is not 1, and the base is positive, the derivative of that is going to be u prime. You get the u prime from the chain rule, natural log of b, and then b to the u. So very, very similar to the derivative of exponential base e. And if you look at other videos, I think we actually derive this. I think it's back in chapter 3.3.7 or 3.8, somewhere around there. We derive that rule. Okay, and then derivative of tangent of u. So in the previous video, I think we figured out the derivative of tangent is secant squared. So this is going to be the same thing. We just get the u prime by the chain rule. So this is going to be u prime secant squared of u. Okay. All right, so we'll go ahead and take the derivative of this. Okay, so the derivative of tangent of 2x is secant squared of 2x, and then times 2. That's your chain rule going on there. Okay, and then times the natural log of 5, and then 5 to the tangent of 2x. Okay, so not real terrible. I'm just going to apply your derivative formulas there. Alrighty, and that's it for this video. I think we have one more video on derivatives. I think we're doing implicit differentiation, and we'll get into a couple of videos on integral review. So we'll see you next time.